Hello everybody, in this tutorial we shall talk about how to convert an asynchronous JavaScript function into a synchronous one. Whenever we read any variable from the server by JavaScript, we use a synchronous function. Nested asynchronous function called generates callback hell type structure. So what is callback hell? Here you see how difficult the code is to follow and read. Probably we should avoid these type of code. We are using an asynchronous call inside another asynchronous call to have control over the code. And this leads us to have this type of code structure. We want to avoid this type of code in our TwinCAT application. So here is the readx function. And it takes one parameter, that is the symbol. And it takes another parameter as a function. That will call back to us with the result. We can check the data and error code to know why error occurred. The data parameter of the callback function will give us the result of the call or any error status. More info at hemelix.com where we have good references. Write function takes three parameters: symbol, data to be written, and callback function. Let's take an example with real data for reading and writing. We have a ready TwinCAT application for that purpose. We need to read two Boolean type variables, and those should be true before we write the output to the motor. If the motor status and door at home are not true, then we should not write the output. We have only two inputs for reading and one output for writing. All data are written asynchronously. Motor output has been configured with the text box. When the output is changed, the text is changed to true or false. If this is confusing to you, check our previous video about data binding with variables. And under the Set Motor Output button we write the JavaScript code for reading, checking, and finally writing the output to motor. Now we write the JavaScript code. Bring the JavaScript code editor. We have already written the code offline and we copy-paste the code to the editor. The code is written based on the readx and writex function that we have shown already. We read the variable door at home, and if that is true, and then we read motor status. And if the motor status is true, then we write motor output to true. In other cases we handle the error. If those functions are not successful, it should have thrown error. Now let us test the application. I log into PLC for observing the output. I bring the TwinCAT live view. Make the PLC program visible so we can see the motor output. Now press the button to set the motor output to true and observe the variable. Motor output was changed to true. Now we compare our JavaScript code and the code from callback hell site. Let us try configuring the action and editor. We commented out the previous code. We drag and drop the condition from the general section. We configure those variables like door at home and motor status. As you see, we are putting one block inside another and making it nested. And finally, if our condition is satisfied, then we are writing motor output to true. Now let us test the application again with the new way. Change the motor output to false if it is true and bring the live view. Also make the PLC application visible so we can check. Press the button. As we see, the application was able to set the motor output to true. If we had more variables to check, then the code would be hard to manage and difficult to read. So it does not look very promising either. This is the same problem. Now we are going to use the read and write function in different way. So we want to get rid of this type of program structure. There is a promise for this in JavaScript. By that we can simplify considerably this problem. JavaScript promises can be a big topic, so I am not elaborating it here, but we shall show how to use it as a developer. More info at hemelix.com. We shall rewrite the HMI program one more time by using JavaScript promise. Promise takes two functions as parameters. Those are resolve and reject. When data is read successfully, then resolve is called with the result and caller can get the result. If the reading is not successful, then we call the reject method with error code or other related info. We follow the following steps to use the promise feature in our TwinCAT application. We don't need any special software for this, all we have in the framework. Create a code behind JavaScript file. Add a new item, then select code behind JavaScript and finally press the add button. We add two functions, one for reading and another for writing data. Here is the function for the reading variables. It will take a symbol as a parameter, but no callback function as we see. We have a function write PLC variable which takes two parameters, one is the symbol, and another one is the data which we are going to write again. As we see, there is no callback function. We can reuse these functions for reading and writing many PLC variables for HMI. So these are generic functions that can be bundled inside a JavaScript library. When the write is successful, then we call resolve with the value. If the writing was not okay, then we call reject with the error data and with the error code. The reject can be caught as an error from where we are calling these functions. Typically another JavaScript function inside our HMI solution. These types of generic functions we can put inside a library and we don't need to see, debug, or test all the time. But we have put those inside our code behind file. Now we try to create a caller functions which can use these promise functions. Let us bring our JavaScript code editor and we commented out what we did so far. The same editor that we have used already in previous two cases. We open the code editor and copy-paste the offline written code. The code what we have written is simple function which will call those functions from the code behind file. If you want to know more about JavaScript that is related to PLC data reading, take a look at our website. We have many good references there. This is our final code for doing the same thing that we did in the other two methods for reading and writing. This is smaller and elegant code, easy to follow. Whenever we call read PLC variable, then we read it and the result is stored on door@home variable. For writing PLC variable, we pass symbol and the data to be written. We are using async and await keywords because we are calling functions that use promise of JavaScript. If any of the read fails, it will throw an exception by calling the reject, which can be caught by the catch block with an error object. We can define the error object by ourselves. This is simply a JavaScript object with the necessary fields. In our case, the object is error data and the fields are error code and error text. See the reject case in the code behind file. Let us try to test the application again. Bring the HMI live view and also the PLC program for checking. Set motor output by pressing the button and see if the variable is changed. So this works, as it has worked with readX and writeX function and also with the action and condition editor. Now let us set the output to false again to do another test. This time we introduce a mistake to see how we handle the case. In this case, we try to test how the reject case throws an exception. We change door@home to door@home1, which does not exist in our PLC program. We test the application again to see how the case is handled. Bring the live view and PLC program visible in the screen. Now we bring the console window for checking the error string that we are passing in the rejected case. Let us position the window a little bit. We can use console log function for log. Now we press the button and observe the motor output. Motor output is not changed and we see text in our console. Error is displayed in the console. Error code equals 3005. Error text equals error in read PLC variable symbol parameter equals PLC1 main door@home1. Because we are passing a symbol that does not exist. Those exceptions are caught by the catch block. Resolve case, we are not throwing any error but we are resolving the result. And here is the error code which we are printing on the console, the error code and error text. The actual error code is coming from the reject case of the promise functions because the status of data from the TwinCAT framework was not okay. And we call reject with error data object where we set the error code and error text. Note how we build the key value pair for the JavaScript object. The reject is translated to an exception. We can use promise much more elegant way. If you put a breakpoint in JavaScript, you can check the error code and possible reasons for failure. There are different error codes on the Infosys site for HMI engineering. We can always consult with the page. Error code equals 3005, which means the symbol is not found or not mapped in TwinCAT HMI framework. You can download the sample code from our site and test it and see how it works. If you have not subscribed to our channel, then please subscribe to the channel and share it in your network. If you are a TwinCAT PLC or HMI developer, certainly there are many code snippet and step-by-step guide at our site. There are many more articles in database, automation, etc. If you have any other questions, you could ask also at our Google group. Thank you.